The next topic is cursors. Cursors are mostly used by developers who are using programming languages like Python, .NET, Java, etc. Using cursors, the program can manipulate the output result set of a query. So let's say you have a large result set and you want to manipulate the movement, and you want to, let's say, fetch records in a particular set or one by one, etc. Then you can use cursors using the programming languages. So what is a cursor? Cursor is an area or a temporary area to hold the output of a select statement. Now remember, it is used only to store the output of select statement temporarily. So if you have a result set, the result set would not be sent to the client. The result set would be held in the temporary location using the cursor. Now why it is created? So after you store the output result set in the temporary location, you can actually retrieve a set of rows or one by one using a pointer, as cursor provides pointers. Now using that pointers, you can move that pointer at your will so that you can retrieve a set of rows. So let's say you have output result set wherein the query produces 1000 records and you want to fetch the record one by one, do some manipulation in your programming language based on the output of the result, and then move it to the next record. So you can do that using cursors. You cannot do that if you run a plain simple select statement. And the result set is materialized on the leader node, meaning the temporary location or the temporary area is created in leader node. So whenever you run queries on Redshift, the queries are executed in the compute nodes and then they are sent to the leader node, and from leader node they are sent to the client. If it's okay if the result set is large, because the result set would be streamed to the client once it is generated, so it will not be stored for a long duration in the leader node. But if you are using a cursor, the result will not be sent to the client, it would be stored in the leader node, or it will be materialized in the leader node in a temporary area. So you can imagine that cursor with large result set will have performance impact. If you are using these type of nodes, RA3, DC2, etc., either single node or multiple nodes, this is the limit of the result set that Redshift allows per cluster, and this is in MB. So for serverless, you can get 150 GB of data. For RA3 XL plus single node, you'll get 64 GB of result set per cluster, and RA3 XL plus multiple nodes will give you 1 terabyte, so on and so forth. How do you create a cluster? Redshift provides a statement or a command called declare. Using this declare statement, we create a cursor. So this is the syntax: declare followed by the name of the cursor, then the keyword cursor for query. Now the query is a select statement. It cannot be any other statement. And the output result set of that select statement would be stored in the cursor name defined here. This is basically a temporary area in the leader node. So let's say this is your result set. Now this entire result set would be stored in this cursor. The name of the cursor is actually cursor in this example, in this slide. Now as I told you that it gives a pointer. So whenever the result set is created and the cursor is materialized, the pointer points to the starting of the result set, not any record. It points to the beginning of the result set. Then you use commands like fetch next, fetch all, fetch forward from that particular cursor to retrieve the rows one by one or in a set. So if you use, let's say, fetch next, then what will happen? It will retrieve one row and then the pointer will point to the next row unless you run the fetch next command again. If you use fetch all, the entire result set would be given and the pointer would point to the end of the result set. Now in fetch forward, you can mention a number. So let's say fetch forward 3. So what will happen? The 3 records would be returned from the output result set using the cursor, and the pointer would point to the beginning of the 4th record. So let's say we have fetch forward 4. The first 3 records would be returned and the pointer would point to the beginning of the 4th record. Now if you run fetch forward 3 again, then the pointer will move 3 records and will be placed at the beginning of the 7th record, so on and so forth. After the operations with the cursor is done, you close the cursor. And once you close the cursor, the temporary area is erased and the storage is returned back. If you want to find out information about clusters, we have these system tables: STV cursor configuration and STV active cursors. Active cursors will show you the cursors which are currently active in your Redshift cluster. So you can use these system tables to take a look at the cursors that are currently running in your Redshift cluster. So as usual, let's have some hands-on on cursor. Before I start the hands-on, I just wanted to mention that the dataset for cursor, merge, and window functions would be different. The name of the dataset is order volumes data, and I have uploaded it in the sample dataset folder under test data order volumes data.csv. So this is the file, and I have already loaded this file in a table called order volumes table in 3IAM database. In retail schema, I have this additional table, or the new table rather, which is order volumes details, and I'll be using this particular table to execute the remaining hands-on. So let me create a new tab with an editor, and let me first set the search path to retail. Sorry, the database has to be changed. So if I do a count star, this particular table has 100,000 rows. So I'll be doing all the hands-on in this 100,000 rows. Now, what will you do in the cursor hands-on? So I have already told you that cursor is a temporary location for your result set. First, let me run a query and get the output result set of that query. This is the query: select star from order volume details, where the order date is between some date range and I'm ordering by country code and state. Of course, this query would run, but what I want to find is the number of rows that the query would fetch. Now I'm running select star. Now instead of select star, let me run select count star and see how many rows I'm going to get. Now using this particular query, I have 750 rows. So my output result set has 750 rows. Now if I create a cursor, that cursor would hold these 750 rows. Now what will I do is that, again, I'll run the select star statement, order by country code and state, and save the output result set of that SQL statement in a cursor. So let me go ahead and create a cursor for this particular SQL statement. One thing you have to remember is that cursor has to be run in a transaction block. So I have started a transaction block in Query Editor v2. This is how you do it, again similar to RSQL. Now this is the cursor statement: declare cursor. The name of the cursor is cursor order volume January 2025 cursor for this statement. So again, this is the same statement that I had run. Now what I have done, instead of just order date between January 1st to January 31st, I have also mentioned order by country code and state. Now this particular cursor order volume Jan 2025 should hold the 750 rows that would be generated by this particular select statement. Now let me execute this statement. I should not see any output result. So as you can see, the cursor declaration is successful. Now I do not see any result because the result set has gone inside of this particular cluster. I told you that there are two system tables that can be used to look at the cursor. So what will I do is that let me use those system tables to see the cursor configuration and the active cursors right now. Now I have not closed the transaction block. If you see, it's begin, and after begin I have declared the cursor. So this cursor is running inside this particular transaction and I have not closed the transaction yet. Now this particular system views STV cursor configuration will show you the configuration of the cluster. So it says what is the current cursor count and what is the max disk space usable. Now it is the disk space that I had shown you in the slide, where it mentioned that for each node type what is the maximum result set in MB. So it is 192 MB for this particular node type, dc2.large 2 nodes. So again, it will be stored in the leader node, so that's why the size is 192 MB. Now let us see the active cursors, and we can find the active cursors in this particular, using this particular statement, stv active cursors. As you can see, I do not see any output because I have not started fetching any data, or I have not started using the cursor. So how do I use a cursor? I use the fetch command. Now what will I do is, if I start running the fetch command, my cursor would be visible in this active cursors list. So let me go ahead and do that. Now I'll run this fetch command, fetch forward rather, and I'll get 5 rows. So if I mention 5, it will give me 5 rows from this particular cursor order volume Jan 2025. Now if I run it, I should be able to see 5 rows. So if you see, these are the 5 rows. 4112 is the last one, which has been ordered by country code and state. If I run fetch next from the same cursor, I should be able to see the next row. Again, it will give me only one row, 29172. If I run it again, I'll get the next row, which is 79550. And if I fetch next again, it will show me the next order ID, so on and so forth. So as you can imagine, if you are running it in a code, you'll have to run it in a loop if you are using fetch next or fetch forward, whatever. So this is where cursor comes handy, because you are getting one row, do some processing in that particular row, get this output in some variables, do some processing, and then either do fetch next or fetch forward, whatever. Now fetch all for me does not make much sense, because it will give me the entire result set. If I want the entire result set, why would I need a cursor? I have not used fetch all, but most of the times developers use fetch next. This is the most used, and fetch forward is also used if you are moving the pointer, if you want to move the pointer using certain numbers. Now if I run fetch forward 5 again, it should give me the next 5 rows from the result set, not the existing ones. And again, if I fetch next, it should give me the next row from the result set. So as the cursor is active, if I go to the second editor and if I run it, I should be able to see that I have a cursor active now. This is the user ID again. This is the ID for query editor v2. This is the name of the cursor, the transaction ID, the process ID, etc. Start time, when it was started, and this is what we are interested in. The row count is 750 and the byte count is 100692 bytes, which is approximately 100 kilobytes, and so far we have fetched only 14 rows. Now let's say I run fetch forward again, so next 5 row, and fetch next again and again. So I have moved the cursor forward 7 times. Now this fetched rows column would change, because now out of the 750 rows I have fetched only 21 rows from the cursor. So I have another 729 rows to go. So you can use this particular view to take a look at the cursor and what is happening inside of that cursor. Obviously we have only one cursor right now. Typically you would see a lot of other cursors, which user has started the cursor, what is the name of the cursor, what is the process ID, etc., row count, and the size of that result set in the cursor. So this cursor is holding a result set temporarily of size 100 kilobytes. Now what will I do is, again, the transaction is still going on. I'll close this particular cursor. Now once we close this cursor, the temporary area should be released and I should not see any cursor right now. So as you can see, there are no rows even though I'm inside of the transaction, right? And as I have closed the cursor, the next step is basically to close the transaction. So I'll run commit and close this particular transaction. Now the cursor is closed and the transaction block is also closed. So this is all about cursor.